Yeah, welcome everybody to our today's weather briefing, which is held by my colleague Andreas Wirth and me, as Marco has already said. I am Yasmin Markl, and I shortly want to introduce myself, as I'm a quite new member of the Austrian National Weather Service, and this is my very first weather briefing. I come from the western part of Austria, from Tyrol, and I have finished my studies of atmospheric science in beautiful Innsbruck just 5 months ago. I am still very new to the subject of satellite meteorology and also the forecasting, but I will try my best to give a short overview about the current larger scale synoptic situation over the Atlantic and over Europe. So, afterwards, Andreas will cover a special topic and introduce you to a new product for cloud phase detection. I have seen some recent weather briefings, and it seems to me like a popular custom to let everybody show where he or she comes from. So I would like you to pick a marker or a pointer and just show where you're from. Yes, there's another one, Christian from Salzburg. That's very nice that you joined. I'm also from Salzburg. I point here. So we have all over Europe. Very nice. Some people from the Baltic states. Very nice. Italy. Outside of Europe even. That's very nice. Yeah. Turkey. Wow. Okay. Denmark. And some people from... Someone is writing something. Venice. Excellent. Okay. So let's move on. And I want to start with having a look at the upper levels of the atmosphere at first. Therefore, I want to discuss shortly the water vapor image of the channel 6.2 from today in the morning at 6 UTC. For this channel, the maximum of the absorption band is at about 350 hectopascal, and this is why this channel receives the radiation only from the high layers. So I guess that many of you are already familiar with this kind of image, and so I want you to give a short or rough estimate about where do you think jet streak could be observed. So again, just take any kind of marker and try to make an estimation. Nice. Yeah. Yeah, very nice. So I see you have some very good ideas about this. So let's move on. I will clear all the markers because now I want you to guess where you could expect a PV anomaly or upper level low. Interesting, yes. Yes. All right. So I think it's not something new. I will just erase the pointers again. Thank you very much. I think it's not very new to you that the darker stripes or areas are the remarkable areas in this picture. Those are areas where dry stratospheric air is brought downwards into lower levels. So this is very useful to detect dynamical structures in the atmosphere, such as regions with PV anomalies or cyclogenesis. We can get some support for this analysis Maybe I have to erase this. No, I'm actually trying. Yes. We can get some support from when we are adding the geopotential at 300 hectopascal, where we can see what is going on in about this level. So we do actually see upper level low here, just in front of the coast of Portugal and Spain and Morocco. We have some very close streamlines up in the north, and also here over northern Africa, where you also have estimated the jet stream to be. And if we go on and we are adding the isoplex at 300 hectopascal, we even see that exactly here there is some jet streak passing over northern Europe, and also here in the south we do have higher wind speeds. All right. So I want to go on and have a look at the EUMeTrain RGB. The EUMeTrain RGB is based on brightness temperature differences. And for example, we have the brightness temperature difference of two water vapor channels, 6.2 and 7.3, which results in a red or brown color. And again, this indicates dry air masses that is subsiding from the stratosphere. As we have seen it before in the water vapor area picture, this would be such an area, or also here, for example, we have this subsiding stratospheric air. The EUMeTrain RGB is also using the brightness temperature difference of two infrared channels, the 9.7 minus the 10.8, and this results in a green color. So basically, this brightness temperature difference estimates the ozone concentration and therefore is a good guess for the tropopause height. Because the tropopause is assumed to be higher in tropical regions, which results into a lower amount of ozone and appears greenish in the RGB. We have this, for example, here in the very south, and this is an indication for warmer air masses. The third component of the EUMeTrain RGB is the water vapor channel 6.2. This measures water vapor in between 200 and 500 hectopascal and gives us the blue color, such as we see it over here in the east, for example, or also here over the United Kingdom and this area. The blue areas indicate colder regions and also with a higher moisture content in the upper levels. What else do we see? We see the thick clouds as these white structures, and it is very nice to see here a huge frontal system reaching Scandinavia today, or with a huge warm front shield and the cold front, which will be very interesting in the near future for almost whole Europe, I guess, and the warm front that has already passed Norway. There is the thick cloud structure from the upper level low that we have also seen before, and here from Greece up to the north, Russia, we have an occluded system that also shows some thick clouds. Well, we can now add the potential vorticity surface of 1.5 PVU, and again here we see that the highest values are found here in the reddish, brownish areas of the EUMeTrain RGB, which means we have some TV anomalies here going on. All right, so let's also have a short look at the dust RGB. Here the red color also indicates the thick ice clouds, as we have seen it before, where the warm front or the warm front shield is. Also the occlusion here in the east is very well noticeable, and here over southern Portugal and Spain we have some thick ice clouds. As the name says, dust RGB, it's also very nice for detecting dust. I think it's probably too easy to ask where the dust could be, so let's just make it short and simple here. Over the yes, exactly, thanks for the marker, Arabian Gulf, we have some dust in the atmosphere, as this pink color indicates. What else do we see? The yellow, orange, or partly also green color stands for low-level clouds. And we also have some almost black and very, very dark signals here, which are cirrus clouds. And yeah, for example, here in Austria or in southern Germany, we have some of this greenish and yellow-orange signals. So if I look out of the window, now we have already blue sky, but yes, this mid-level, low-level clouds have dissolved over, or like today in the morning, and yeah. We are lucky to have now some sun here. This also brings me to the webcam pictures I want to show you, just to have a better feeling about how it looks in real life. I have picked Bergen, Norway, where the frontal system is approaching, and we do see very thick clouds. There was also rain in the morning, and yeah, a similar situation is observed in Lisbon, in Portugal, where this smaller system is approaching, and here in Kufstein, in Austria, which is my hometown, we have blue sky, and this is actually quite close to Salzburg, where I am sitting right now. This was the situation for 8:30 UTC in the morning, and this is how it looked at 11 UTC in the morning. So Bergen is still very cloudy and wet. Lisbon also very overcast, while Kufstein, Austria is just sunny and nice. So now I want to pass the microphone to Andreas, and I think if there are any questions left, we should probably discuss them in the end. Thanks a lot.
Thanks, Yasmin, for this nice presentation of the present weather. I wish you a nice afternoon. I'm sorry a little bit, because in my building there's constructions ongoing, and I hope you won't be disturbed by too much background noise. So what I'm going to present to you today, I was thinking about different topics, and I selected an NWCSAF product, which is quite new, and maybe you have already installed the product or the program in your offices. There is a new product called CNIC, Cloud Microphysics, and one of the products is the Cloud Top Phase product. And I would like not to do an evaluation, but just to show you my first impressions of the product when I compared them to satellite images, especially RGBs. And some of the RGBs are sensitive to ice and water phase, so I took two of them and compared the Cloud Top Phase product with these RGBs. So as I told you, here you see in the slide, The ZAMG product is part of the NWCSAF release of the version 2016. Here at ZAMG, we installed it early this year in January, and it became operational since February, end of January. So I have not a long experience, but I looked at some cases and I will show them to you. If you want to know more about the product, you can go to either the real-time images, which are here. Looks like that. You have them in different resolutions, and I think every hour. And you have also a short introduction into the product. PGE 15 is also called the ZAMG product. So you can go there. Here's the address. Go there and get some more information on that. But maybe you know all of that and you have already seen the results. By the way, I have also taken this the results of this cloud top phase product and included them in ePort Pro. So if you are in layers, you go to product, then you go to NWCSAF product, and here you will find the cloud top phase. So you can easily see it. I selected the colors which are recommended by the NWCSAF. I didn't change them, but maybe we should think about changing the colors. I will explain why a little bit later. So the first image I compared the cloud top phase product with is the night microphysics. Why the night microphysics? We have the 3.9 micrometer image, which is sensitive to two things, to the cloud phase and also to the droplet size. And this difference here is used to analyze the fog, the low-level water clouds. The red beam corresponds to the cloud optical thickness, so low values for cirrus and higher values for thick opaque clouds. And the blue is just the temperature of the cloud. So the following example, but I selected different examples, but the next example is a very recent one. It's from 15 March at midnight and taken from ePort. So here it is. Now something to do for you. Please select the fog areas or the low cloud water clouds. Select them. Where are they? It's a very recent image, so maybe you can still remember this cold front passing. Exactly, very good. Yeah, you concentrate on the left-hand side of the image. What's on the right-hand side? Yes, very good. Now this green rectangles mark high clouds. So this here are high clouds. The low clouds are, most of you are correct, are here exactly, and here. Big band of low water clouds. Very good, thank you. Also here, okay, yes. You will find also some small parts. Yes, very good. I think you are used to work with this image. Now the next image will be the cloud top phase product, and we will see that these regions will quite good coincide with what you have selected here. So let's go there. Here it is. So liquid water clouds are orange, ice clouds are blue. Then there are mixed phase clouds, which are brown. And unfortunately, this is a criticism I have to this product because I just took the recommended colors. The undefined clouds are very similar to the mixed phase clouds. So maybe this should be changed. Cloud free, of course, is black. There's no color at all. So this cloud band, as you have selected it here, is depicted as water cloud. Very good. And here the northern part of the clouds you have also selected are water clouds, but also the more reddish clouds are seen as water clouds in this cloud phase product. So the next image shows you again the night microphysics image, but I have selected some points, and there you have the RGB values for some areas, especially the areas you previously selected. And you can see that the red color beam is quite similar for all three regions. The yellow, oh sorry, there's no yellow. The green is also Very similar, 207 here. I hope you can see it. 207, and a little bit higher here. This marks very intense fog, while this here is not so intense, but this here is a bit stronger. But the big difference here is the blue value. Low blue value means cold cloud tops, and higher blue value here, and even more higher here, means warmer cloud tops. So here in this region, we have cold fog, and the higher blue intensity in this region, behind the cold front, marks the warmer fog. So warm fog opposite to cold fog. The cold fog is a little bit more greenish, and the warm fog is a little bit more blue. Oh yeah, before coming to this here, I told you that some parts here are more reddish. So still, this is a water cloud here, but the color is more reddish. Why is it? We will see it on the next slide. That's the cloud type product, also from the nowcasting.saf, and you see that these areas are yellow. That means these are a little bit higher clouds. So I see that there's a question in the chat box. These are 0 UTC images, because I take them at midnight. The night microphysics RGB does not work during the day. Okay, so the night microphysics low clouds are a little bit more reddish when the clouds get higher. That's what you can here see with the yellow regions, which mark the mid-level clouds here. So there's another RGB, which has the 1.6 micrometer image. This one is only sensible to ice and water phase. So it's a good candidate for comparing this RGB with the product. It's very simple RGB. You know, here you see here the recipe. Ice clouds appear in cyan colors, and water clouds appear whitish. Snow on the ground is also cyan, so it's very difficult. No, not very, but it's a bit more challenging to separate ice clouds from snow on the ground. This is not very ideal in this RGB, but at least snow and ice can be separated from water clouds. And thin ice clouds are more or less transparent in these images. This is a big drawback of this RGB, so thin cirrus clouds will not be detected very good. The following example is from Saturday, 11 March, 12 UTC. So here it is. I think, as Yasmin formulated it, it is too easy to ask you where the ice clouds are, but it's quite simple. So everything which is cyan is ice cloud. Oh, and this here is snow on the ground, exactly like here, snow on the ground, same color, but just from the morphology you see that it's not a cloud, and ice cloud of course here. So the next image will show you the cloud top phase product, and you will see that this corresponds quite good to the frontal system with high ice clouds. And here in the Alps there's no snow, so that the masking of the snow on the ground works quite well. Same here, it's not apparent anymore, so this separation from snow on the ground is quite good. Ice clouds are blue, water clouds are red, orange. So what about the cirrus clouds? I have an example here, also quite recent. I forgot the date, but it's from the day before yesterday or from yesterday. Here you have some cirrus clouds here, and they are getting thinner and thinner in this direction. Here we have a lot of cirrus clouds. Here we have some cirrus clouds, and also here we have cirrus clouds. So what's happening with the cirrus clouds in the cloud top phase product? You see that they are quite well resolved in this image, in this product. We have them here. And I told you before, in this region, the cirrus clouds get thinner and thinner. So what you will see here is that very thin cirrus clouds are marked as undefined clouds, not as mixed clouds, but as undefined clouds. Also in the margin of the ice clouds, cirrus ice clouds, you will always find some undefined clouds. So the product is not able to resolve very, very thin ice clouds. This is one of the drawbacks I saw just in this image. But at least the product recognizes that there are some clouds. But it cannot say anymore if these are ice clouds or water clouds. Let's continue. This is my last example for this weather briefing, because I told you I just had a very quick look. Again, the natural color RGB. 3 regions I selected here. One with in the vicinity of ice clouds, so one could maybe see that there are some very thin ice clouds. Here, obviously, in this circle, there are no clouds, and here we have water clouds, and probably I think these are ice and snow on the ground. But we shall see what the cloud top phase product says. If we continue, then you see, okay, you see that there is some thin ice cloud, but even much more than we could see from the natural color RGB. Here we see that this is mainly ice cloud, and what is not here anymore is the snow on the ground disappeared. And here, in this region here, where we thought there are no clouds at all, there are some thin cirrus clouds, but they are so thin that they are not analyzed as water or ice clouds. As I told you before, they are analyzed as undefined clouds. But still, in the RGB, in the natural color RGB, which is often used for discriminating ice and water clouds, there was no indication of any cloud. So these were my first impressions of the product. If you want to have more, want to see more, you can see them 4 times a day in ePort Pro. I think you have all access to that. If not, then send me an email. I will grant you the password, send you the password, and you can watch at the products if you do not have them at your office. So thank you very much, and I give back the microphone to either Yasmin or Marco, I don't know.
Well, I think that's all for today. Yasmin, do you have anything else to add?
No, I'm good.